Hi there, my name is Spencer Sheen, and in this video I'm going to walk you through how I create graphics like this one showing a shaded relief map of Acadia National Park. In this video I'm going to rely on a repository I've been working with for a long time, and you can find it on GitHub. My username's Peckners and the repository is Rayshader Portraits. You can fork this repository, you can download it and work from it. I'm going to be using some custom tools that are in this repository. So just know that going forward, check it out, do whatever you want with it. And anyway, hope you enjoy this tutorial. All right, so the first thing we want to do is use this new portrait function. And this is a message that will pop up anytime you restart your session or start a new session in this repository. So we'll use this new portrait to get started, and we're going to be making a portrait of Acadia National Park, so I'll call the map Acadia. And then the template, I don't have this documented super well, but the template can either be population or elevation, and we are using elevation this time. And there we go. Okay, so what I just did with that function, you can see over here the file structure. We're in the home directory right now. And then if we look at R and then the portraits, that function, this function here, created this subfolder, Acadia, and it pulled in some template scripts that are really good for getting started. And you'll see as I work through this, I'm not going to use every line of code here, but it's a really good starting point. So let's go ahead and get started. First, let's load all of our packages. We define the map here because I'm going to use that later for naming files and such. Now, this next chunk of code is assigning to a data object the boundaries of a given national park. So you can see here I'm reading in this shapefile, and this contains the boundaries for all national parks in the US, and I have the URL here of this data, the source of the data. But so we read it in this first line, and then we filter it in the second line for the park name. And you can see we're calling map here, so it's going to be looking for Acadia. And then we're transforming it to 3566, and I forget what that is. Let's just hop over here and check it out. That is Utah. So Utah is not what we want. That must be what I set it for the default on accident. So let's just search main EPSG. Let's go with 2802. All right. Now, this next bit of code is useful if we're creating an inset map in the final graphic. I'm not sure I'm going to do that this time, but this is not, too onerous on our process. So I can go ahead and load those elements. And that way later, when some piece of the script tries to save those elements, it won't be an issue. Okay, so next, let's go ahead and plot data just to see what we have. All right, and there we go. So these are the boundary. This is the boundary of Acadia National Park. Now, next up, we need to download the elevation data. And to get the elevation data, we're using this package, Elevator, Elevate R, however you want to pronounce it. And with this package, you can download the data based on a an SF object. So in this case, our data object, which defines these boundaries, it's going to pull in the elevation data limited to these boundaries. And we have to set the Z value because that's the resolution. And Z of 14 is the highest resolution. I usually start around 10, and I'm aiming for an object returned in the range of like 1 to 5 megabytes to get started. So we'll see what that gives us. Okay, 6.4 megabytes. That's good. That's a little bigger, but we can work with it. And the reason I want that range, it's actually a lot lower than what the final render is going to be, because as I'm working with the data, I want something smaller that the script will be able to run faster on, because I'm iterating and, changing small settings, and I don't want it to take a long time to render because it's a massive data set. But when we're preparing for the final render, I'm going to kick that up until it's like 300 or more megabytes. Okay, next we need to convert the raster object, which is what this Z11 object is, to a matrix, which there's this handy function in the Rayshader package, so we can go ahead and do that. Next, let's set up a color palette. This is just a default color palette we can use to get started. I'm probably going to change that. Let's see. This next bit of code, I'm going to comment out because I believe I don't actually use that anymore. I think it's just here from when I created this default script. I used to use it. Now let's set the shadow depth. So this is going to be how far below our object the ground is, and that's where the shadows will be cast. So I generally set that at 500 feet below the lowest point of our data. The resolution here, this sets the ratio of the height to the XY axis. And so I usually set it around 5, which is what this is doing. And then we can move forward, and this bit of code will go ahead and create our 3D object. So there we go. Now, in this RGL window, you can play with it. So I can grab it and move it around. And you can see the shadow depth here. This is what I'm talking about. How far below the data the actual ground is. And the Z value is how drastic the heights are, or how exaggerated the heights are. So, for instance, instead of using this line of code, let's set it to 5. And every time I rerun this, you'll notice I'm going to close the RGL window so you can see it's gone. And I do that so that it plots a new object instead of trying to plot it on top of the other one, which creates some issues. So then I'll go ahead and run that again. And we can see, all right, it's a little more exaggerated now in terms of how high it's going. Now let's change that to 10. So we move the Z value up. And it's a little less exaggerated. All right, now let's go a little more extreme. Let's make it 50. So let's move it way up. Now look at that. It's pretty much flat. All right. So that's just to give you a sense of what the Z value is actually doing. I'm going to turn it back to this res value because I like that. This is a good, it's a happy medium between extreme exaggeration of the heights, but it's still exaggerated enough to make striking shadows, and it just looks really cool. So the other thing I want to do is I'm going to raise the shadow depth. So I used to make these graphics where the shadow depth was set to about this, but I'm going to change this so that the shadow depth is at the minimum value of the park. And as an example, here's Joshua Tree National Park. This shadow depth is set at the minimum value of the park. So that means the ground is basically up meeting the lowest point of the data. So let's go ahead and do that by just deleting this minus. So now it's going to be set at that minimum value. Actually, let's take it down just like 0.5. Just so we make sure the shadow isn't erasing any data. Now if we pull it down, it looks like we're set right on the ground. All right. So now moving on, this next line of code just orients the frame at specific points. And now these next few bits of code are preparing to render the graphic. So I'm going to create a directory for the images we'll be creating. And it's going to be in the images repository, and it's going to create a subrepository named for our map object, which again is Acadia. So if we go back, images, and I should note, if you are following along, if you've forked my repository or downloaded it, images is ignored. It's in my git ignore because these files are huge, so I can't track them on GitHub, so you'll need to create this directory yourself. So I've already run this script before, so I already have an Acadia here. It's empty right now, so I'll go ahead and delete this for our purposes. All right, but run this script, and now we see Acadia's back. So it created that directory because it didn't exist. Now I'm going to create the out file name, which is a combination of the map, the palette we're using, the color palette, and the Z value. And the reason I do that is because I'm going to work through a lot of different combinations of those elements to create the map that I want. And I'm going to want to be able to compare which I prefer. And so I don't want to be overwriting the same image over and over again. So let's go ahead and run that. So now we can see our out file here. That's what it will be. Then I'm going to save this list element, which has a lot of the information that will be useful to us later. I'm saving the map name, the palette we're using, the Z value. All of that's going to be saved as an R data file that we can access later. And you can see I'm saving the coordinates too. The coordinates were up here. So this chunk of code that I said we're probably not going to use, but I'll go ahead and run it. So that's why they're coming into play here. I save those for later in case I want to render an inset map. All right, and next, and lastly, this is the chunk of code that I will use to render the graphic. And you can see this is an anonymous function. This chunk is the actual render high quality call that creates the graphic. Everything else is just some bells and whistles I've added on. First of all, this will make sure that the out file you've set can be written to, so there's not a problem in your file path or anything like that. I think Rayshader has been updated to account for this, but at least in the past, you could put in a bad file path. it would go through the whole rendering process, which could take hours, and then it would fail to save the file, which was frustrating. So I built this in, and then I clock how long it takes with by start time, end time, and then these cat calls are just showing when it's starting and when it's ending. So just some helpful messages to me that are going to play out in the console. And finally, I've updated this chunk in other graphics like this one. So I'm actually going to hop over here, and instead of working through rewriting that graphic or that code chunk again, I am just going to steal this. All right. Some of the key points of this chunk are the light elements. So these light elements are creating the direction of the light. And you can see there are actually 4 values here. That's because I'm creating 4 sources of light. And then setting the light color. I'm also using 4 different sources of light color, or 4 different sources of light. Each has its own direction, its own color, its own intensity, its own altitude. So we're setting all of that. But right now I have this set up to render as a really high quality image. And I'm going to dial that back just as we're editing here and getting ready. So first thing I'm going to do, I'm going to change samples from 450 to 300. I'm going to change preview to true. And I'm going to make the image smaller. So 600 instead of 6,000. And then with all that, we can go ahead and run this. And let's see what it looks like. Object LC not found. Oh, I did not have that object. And again, that's coming from this code that I copied over. So I guess not surprising that there was an element that isn't in this script. Let's try it again. What? Where is LC? Ah. All right, one more time. All right, there we go. Now it is actually rendering. This is not at all what I want, though. Oh boy. And part of the problem is these light elements that I pulled from here are based on the palette that I have set up here, which is different. And there's LC. There's that LC element. So I'm going to pull this over too. I'm going to change the palette we're using. So like I said, this was just default. That's a good starting point. I'm going to change that. So let's go ahead and prep this. So this is what the palette looks like. All right, let's give that a shot. All right, it's looking better to me, but it's still a little bit, still needs some work, I would say. I thought, what is going on here? Oh, texture is texture. Okay, so see, I have the texture defined here. And then we need to call that texture down here properly. And then, so at this point, I'm just dialing in the coloring that I want to use and re-rendering to get an idea of what it's going to look like before I initiate the full render. Oh, okay. That warning message isn't anything to worry about. When we do a full render, it's going to go away because we're going to up the samples. Now let's get back to this. Okay, so this is the texture that's being used right now. And let's look at colors again. So we're taking 9 to 5 colors. So these orange colors, let's add in like 1 to 2. So what if we do that, I wonder? I want to move the bias. All right, that's kind of neat. Let's see what that does. Kind of just blurs in, doesn't it? You know, there was one other one that I just did that I want to take a look at. Hot springs. So this is what I do a lot. I will just look at other examples I've used and try to make different combinations that have different impacts on the overall graphic. So what did I do here? All right, here, I'm going to pull this one. I need to update this again. So this might look a little bit different because I just pulled it from a different map, but it's essentially the same. And then, all right, 300 previews on, 800, 800. Let's try it. And what this one looks like here, I just posted it on Twitter, so it's this graphic. All right, let's see. Okay, I want to go back to this. Oh. Okay. Go back to that. Let's see. I want to get rid of this. All right, so now we're back to an all orange palette. I think I like it. Okay, let's move the light source a little bit though. What if we make it like 95, 95. So this is going to be close to due east. 100. Let's drop the altitude a little bit so that it's more dramatic. All right, give that a shot. Here's the image that's being created. Seems a little drab, doesn't it? Okay. I think I'm happy with this. So I have this dialed into a way that I'm feeling good about. And what I've done is I've changed the colors of the two main light sources. And, well, I guess I haven't explained any of this. So the reason I'm using 4 light sources is I have 2 colored light sources and then 2 white light sources. So the individual colored light sources are offset slightly. You can see I have them coming from angles of 95 degrees and 100 degrees. So that slight offset has an interesting effect on the shadows. And the reason I have the white colors also, the white light sources, is because those are coming at a much higher altitude. So it's more like they're coming straight down on the scene. And that has the effect of limiting the severe shadows that would show up if I was just showing the colored shadows coming at the 15-degree angle. And finally, you can set the light intensity. So you'll see I have the intensity of the 9th element of our colors. So this color here, that's the highest. The white elements, I have them set at 75 intensity. And then the other color light is this one, and I have it set high, but not as high as the orangish one. All right, so now that I have all that good to go, now I'm going to go back and increase the resolution of the data. So let's try 12. And so my rule of thumb here is, as long as I keep it under 500 megabytes, I should be good. Okay, that's actually 100 megabytes, so I'm going to try to bump it up one more notch. And the way that this increases, going from 12 to 13 can be a massive increase in the size. So I'm guessing this is going to be too much for me to handle. Nope, that's only 400 megabytes. So it's still a lot, but I can deal with it. All right, so now we have all of this. All of that is good to go. Let's see. Now, what I like to do is change all of this back to what I need it to be. I turn preview off because on these high resolution renders with larger amounts of data, I've had it crash more frequently when I have the preview on. And so that can be frustrating. So I up the number of samples. That just increases the resolution a little bit, makes the image a little better. I am increasing the size back up to 8,000. It's a square image, 8,000 by 8,000 pixels. You can set whatever you want. The higher you set it, the higher the resolution will be, you know. Okay, so now I am ready to run the script from here on down. And instead of sitting here waiting for it, I like to just run the script as is. Because it'll just go and I don't have to watch it. One thing I want to point out is this resolution, this res argument, is a lot of times at this point I would forget to now go in and update the res, which I need to do because I am using a higher resolution of data, which impacts the ratio of the height to the XY coordinates of the map. And so a lot of times the impact of that is when I forget to change the Z value here, this value, and I re-render this with higher resolution data, the map comes out looking very flat because the ratio's off. So that's why I have this argument defined, or this object defined res, because it sets the resolution based on the resolution of our data. So anyway, just avoiding that headache. And like I said, let's just go ahead and run it. Now, this chunk here that just renders the image, it's going to take a little longer to render out here because it's so much higher resolution, but it'll work on that. Eventually, you'll see the object appear here, and then you'll see shadows appear also, and that's when it's finished rendering the image here in the window, and then it will move through, oh shit, and then it'll move through the rest of these lines, until you get down to here, and you'll know it started this script because I have these cat calls. So it's going to tell you the start time when it actually starts rendering. So I am going to pause here and let this work its magic. All right, now we have our final high quality graphic rendered. And it looks pretty good. I'm happy with this. Even if we zoom in, you can see the detail that this provides. It's pretty cool. So our final step here is to prepare the final image that will be cropped and annotated. So for these final steps, you could obviously use whatever photo editing software you prefer. If you want to use Adobe or Canva or something like that, or Figma. I like to use R because I have a workflow built into this already. So as you'll see, I can just copy code I've already written. But feel free to skip this part if you want to just drop this into Adobe Illustrator or Photoshop and start playing around. All right, so first things first, I'm going to go ahead and clear all of this because we don't need it anymore. And you'll recall that when we used our new portrait function, it created a whole repository here that had some other template files. So we're going to look at this markup file. And this markup file, actually, I'm going to steal something else. Let's just steal. So I'm looking for another graphic I've done so that I can steal the code from that because it'll just be quicker. So I'm going to steal this. Okay. I need to update the file paths though, because this is saying New Mexico. Obviously, I need it to say Acadia. I think that'll do it. Let's see. Yep, that looks right. Okay. But I usually do Control F here to find all the instances that I'll need to change. So in this case, it's all the New Mexicos. I need to change with Acadia. And if you put a slash in there, it helps you find the ones you're looking for. So let's say replace, replace, replace. That's all of them. And then I'm going to update this file path, Acadia. That's good. Okay, so first things first, I want to just crop this image. So we're using Image Magic here. I'm not going to get too in depth about what Image Magic does, but there's a lot of functionality you can use to edit images. So you can crop images, you can do a lot of more complex things, you can annotate the images as well. So I'm not going to get too creative here. I'm going to crop the image and I'm going to add some text to the image, and that's about it. So first we've read in our image here, this IMG object. This is our image. So here, this chain, we're passing the IMG object to image crop. So this is going to crop it. And we need to set the dimensions of the crop. So first, I forget what the dimensions we set were. So let's just, you can use image info and it'll tell you, okay, it's 8,000 by 8,000. If I look at this, I probably want to crop it like, I don't know, 7,000 by 6,000. Let's see what that does. And I have all of this code commented out. So all this is going to do is it's going to crop the image and then it's going to write the cropped image to this file. So if we do that, then we need to hop back over to our images file. And when this is done writing, you'll see it appear here. So this process does create a lot of intermediary photos, image files. So if that annoys you, you might need to come up with a workaround, but it does not annoy me. I actually like having the intermediaries. I find it helps me work through the process. So I think that looks pretty good. We can even try let's see, that's 7,000 wide, 6,000 high. What if we made it a square? Let's try 6,000, 6,000. All right, so there, that works too. So I'd rather have it be a square, because that, if you do end up wanting to create a physical poster print of this, it's easier to work with the square than 7,000 by 6,000. You would want to adjust the aspect ratio a little bit to get something that's more in line with the more common poster sizes, like 11 by 17 or 18 by 24, that sort of thing. Okay, so now that we have it cropped, we can start annotating. So I'm going to uncomment this section. And I want the annotations to read Acadia National Park. And if I look at this, one thing, actually, I want to try something a little goofy. I want to try ACADIA like that. And then we can say National Park over here. And this way makes good use of the space that's open to us in the image, I think. This blank space and this blank space. I think that, I don't know if that's going to work like I think. I think that'll create a new line. I think it won't print the /n, but let's see. Yeah, okay. So the color's not what I want, the placement isn't what I want, and the size isn't exactly what I want. But it's a good start. If we look at plots here, we've plotted the color palette, so we can go ahead and steal one of these colors. I'm going to try this one, which is 1, 2, 3, 4, 5, 6, 7, 8. So let's call it colors 8. And then we need to move this left and move it down a little bit. So we're starting with the gravity set to north, which means the starting point is here in the middle. And then for every plus on the x argument here, which is this first here, it's moving it in this direction. If you do a minus, it'll move it in this direction. And then this argument is the y value, and that's telling it how far from this anchor point, the north anchor, it's going. So I want it to move a little further down the y, and I need to move it negative along the x, so this way. So let's try we also want these to be a little bigger, I think, so maybe 500, more spacing. I think line height is an argument. Oh, I have to say equals. Okay, it's not an argument. Anyway. Okay, so that is way too much spacing. What did I do? Oh, I had an extra 0 there. Okay. Other than that, I think this, so it's going to be centered about here, so I still want to move it over left a little bit. So let's make it 1250. I think the height is good. Let's see what that looks like. Okay, I want to move it further left still. Probably down a little bit. Let's just say 1,000. And I want the spacing to be more. Okay, new idea. Let's say Acadia. What if we say Acadia across here and then National Park down here? We'll have to try to create a visual hierarchy there to make this work. I'm not sure if it will. All right, we're going to want this to be like 700. This is going to be center now. I want it to be centered. So center will be about here. We probably want it down 1,000 still, but +0. All right, I actually think that looks pretty cool. I went a little farther, so let's try 750. And let's up the kerning a little bit. If you're unaware, the kerning is the spacing between the letters. Okay. Still want to make it higher. Still want the kerning to be bigger. And okay, so the next step I'm going to do is to add National Park. So let's say National. Let's start with National. Colors. So I want the visual hierarchy to show you Acadia first and then National Park. Again, I'm not sure this is going to work. Okay, I didn't put it in the right spot again. But it's a start. I want it to be darker, so let's try colors 2. Let's move it over. All right. That's kind of what I was thinking of, but it is maybe a little too hard to see. Acadia. What if we put the National down here and the park over here? Okay, I think that looks pretty cool. And the last part is to add your author credit and data source. And when I add these, I like to add them, you know, in a bit of a clever way, something more interesting than, you know, along the bottom of the image. So I like to underline with a line of text. So I'll put that text here and it'll act like an underline of this. At least that's my intention. So let's see if I can pull it off. So this final code chunk is going to add that the graphic is by me and the data is from AWS terrain tiles, because that's where Elevator is pulling from. Now we need the gravity to be the center because we're trying to go below Acadia. Let's see, this is all Amarante. Okay. We want it to be centered also, so we'll have 0 movement on X. We went down 500 here, so we probably need to go down like 1,000 maybe. We'll see. I think I'm going to go for this color, so let's say colors 7. All right, let's just see what that does. Okay, so I'm down a little far, so let's move it up. There you have it. You can make this your own, of course, but I think I'm happy with where this is and ready to call it a day. If you have any questions or feedback on this video, please leave them in the comments. Feel free to reach out if you want to email me. Otherwise, thanks for watching.